To see the Leetcode question that we have 103 binary tree zigzag level order traversal, right? So this question 103 question is very important because this question has been asked in the Hang multiple times, right? So given the root of binary tree, right? The root of binary tree is given, and we have to return the zigzag level traversal of its node values, okay, from left to right and then right to left for the next level and so on. Okay, so if I'll talk about the level order, right? So the first it is saying left to right, right? We'll start from left to right. If this is left, right, this is right, correct? So first we will start with this one, right? Then again it is saying from right to left. Now we have to go to right to left, right? And then what is saying, it is we have to go with this one. Means first we have to go like this, then we have to go like this, then we have to go like this. Okay, so this concept, you can say, if we are going like this, right, you can represent this one in like this. We have 3, next we have 9, 20, then 15 and 7. Okay, so if we have the node like this and we have the tree like this. Okay, so what we have to do, we can go by from this one, we can go like this, right? Because we have come from like this. Okay, now we will go like this. Okay, now once we reach here, right, what we can do, we can, sorry, we can come and we can go like this. Okay, sorry, this is the way you can implement, you can say we can go like this. Okay, so this path is called zigzag order. Okay, so if you see that first we have visited what, 3, then you can see that what we have visited, right? Then we have visited 20 and 9. Next time what we have visited, 15 and 7. Okay, so these visited nodes we have to return each time, and that will be our output. Okay, so this is called zigzag order traversal, and that we have to return it. Okay, so uh, another what we have, if there is only one node is there, right? So if you will visit, this will be look like this one only, right? If this is empty, you will get this one. So Google has asked, I think, more than 9 times, right? And it is, you can say that this is a very important question. Okay, so I'll suggest, uh, please go through this one and try to implement this one. Okay, the first thing is that our approach, you can use BFS, DFS, right? Breadth first search and depth first search you can use, right? The most you can say intuitive solution would be the best first search, right, approach, through which we iterate the tree level. You can say we can traverse the tree level by level, correct? And the default order, default ordering of BFS with you can say a single level is from left to right, right? When we do BFS, right, in the single level we do from left to right, right? So as a result, we should adjust the breadth first search algorithm a bit to generate the desired zigzag ordering, correct? So one of the key here is to store the value that are the same level with the DQ, double-ended queue, you can say, data structure that we have, where we could add a new values on other end of a queue. So if we want to have the ordering of first in, first in, first out, FIFO, right? Means first in, first out. we simply append the new element to the tail of the queue, and then what happened? The latecomer stands last in the queue, you can say. While if we want to have the ordering of philo, right, first in last out, then we will insert the new elements you can say, to the head of the queue, correct? If we use philo, where we add on the tail of the queue, right, on the tail of queue. But if we'll use philo, first in last out, then where will you add? On the head of queue, right, for all those latecomers that will jump into the queue, correct? Now think about previously that we have seen, right, this one we have gone this zigzag, right? So there are several ways to implement these zigzag things using the BFS algorithm, right? the one would be the one would be that we run a two level nested loop. Okay, the first, what we can do, one way, we we can run a two level nested loop with a single, with we can single outer, right? Yeah, with a single outer loop iterating over the, you can say, tree, right? Each level we will iterate a loop, right, within a single loop, iterating each node with a single level. Okay, so we could also simply implement BFS with a single loop. The trick is that we append the nodes to be visited in the queue, and we separate node of different level that sort the delimiter empty nodes. The delimiter marks the end of the level as well as the beginning of the new level, right? So what I'm saying that we can, there can be multiple approach in which what we will do. The first way, in which we will run two level nested loop, right? Two level. The outer loop iterate each level on the tree, and the inner loop iterate each node within a single level. So we could also simply implement BFS with a single loop. The trick is that we append the nodes to be visited onto queue, and then we separate each node of a different level with a sorted delimiter, right? The delimiter that we will use, that will mark the end of the level. So as well as what we will do, as well we can use on the beginning of the new level, right? So we want to you can say that if you will use the second level, right, second level, so what we can do, we can start the normal BFS, upon which we add a touch of zigzag order with the help of DQ. So for each level we will start from a empty DQ container to hold all the values of the same level, that depending on the ordering of each level, either from left to right or right to left, right? So we decide that at each end of the queue DQ to add a new element. So if I'm saying, if we have 1 2 3 4 5, right, this type of element we have, right. So what we will do, if this is head, let's suppose, if this is head, right, if this is our head, so we will insert what, where, here on the tail. What we will do, we will do insert. So from left to right, this is from left to right, right, and here we will use what, philo. Okay, but if we have like here, let's suppose 5 4 3 2 1, 5 4 3 2 1 means we will go like this, right? So in this case we will insert here, insert at the you can say head. This is our head, right? And what we have, this is our tail, right? So here we will go with what, right to left, okay? That is we can say philo, that is our this is our philo, first in last out, yes, and this is our FIFO, correct? I think you understood, right? So for the ordering from the left to right, that we will use the FIFO, we append the new element to the tail of the queue at here, that is our FIFO. We append the new element to the tail of the queue so that the element that comes late would get out late as well. So as we can see from these two graph right here, so the first graph 1 2 3 4 5 with FIFO ordering, and we would have an output sequence of 1 2 3 4 5, correct, similar. And for this one that we have created, the ordering of the first you can say from the right to left philo, we insert the new element to the head of the queue. So the element that comes out late would get out first with the same input sequence of 1 2 3 4 5. With philo ordering we would obtain an output sequence 5 4 3 2 1, right? So this will be our you can say approach, and we can also do some alternative approach in which we can implement the normal BFS first, and which will generate the ordering of left to right for the each level, and then at the end of the algorithm we can simply reverse the ordering of a certain levels, right? And then we will do the zigzag steps, right? That we can do that. So in this case let's understand this one, in which we will see this zigzag thing, right? So first what we will do, we'll check if root is null, then we will return the empty array. We are not going to send anything, that will be empty. Now we'll take a result in which we have to pass the list of lists, right? So we will take list of list, right, as a result of the nodes, right? And then we will have what q nodes, right? You can say q, and we will add the root first and one null. So always when we will insert here, let's suppose we have q, right? So always insert two things. The first is the node, right? First should be node, okay, and another is null, right? Two things we have to add into each level, in each level, right? You can say in each node, right? So the first we will add root, and another is null. Now the we have to add first level list. Each level we have to do, so we will take one, we will take a level list, so that each level we will have our list. Now we'll check is order left, right? So each time if you will traverse, like we have what 3, we have, let's suppose example 3 5 8 9, like this we have, suppose, right? So what will happen for each level? So there is one element, we will take one element, but here is two element, right? So we will take two into as a list in each level, right? So in this level we have two elements, but one element, so we will add. But we will take one more thing, that is order level, is order level left, right? Is it is going from here left to right, right? So in this case we will make it true. Why? Because if the first time it is moving in this level, if it is left to right, means next time it will become false, correct? If first time it is true, next time it will become false. So we will take one, this one. Now we will check if the queue is not empty. Obviously we have added a root, so we will go into this while loop, correct? And here we will check what, we will check our you can say Current node will take from getting out the first element from the first pull out we will do from the queue, right, and we'll get our current node, right. Now we'll check not empty, then it will check is it left, right. So in the initially we have added a queue as a true, so we'll say that we are going from left to right and it is true, so that we will add on to the first level, right. So we'll take the current node dot value, means we will add our root node into the level, right, level list. So there will be some level list in which we will add our root value. Let's suppose 3 we will add there. Now else condition will not work here because this is not right one, this is left order. So we'll continue here. If left is not empty, current node dot left is not empty, then we will move to this level, right. Now what will happen, we will first add this node here, right. We will add node, and if this is right is not empty, then we will add our right also. So two things we will add here, right, and then these things will get it will get continue, right. Another thing, once we will have our you can say what we can say, the level, right, then after the finish the level, we scan the one level, right. How we'll do that, we'll add onto the level, right. We'll add the first level, that first level we have already traversed, like for the root. Then we will add onto the result, and we'll say uh, level list is nothing but our we have to actually we have to initialize this one again. Once we have added on here, so we will reinitialize, so that the previous value will get cleaned here, right. Like first we have added 3, now we have to add 4 and 5, right. So that we will reinitialize this one. Now what we will do, we will check if node dot you can say node queue is not empty, then we'll add a null, right. If this is not, so each level we will add a null, right, and then we'll check if left is not equal to left, right, then we'll continue, and this while loop get continue and will update our you can say final result. Each level will add into the queue. So first it will come 3, next time the list will contain what, 4 5, right. So it will come 4 5, right. First is 3. Similarly we'll get the other things here will onto the, and this is nothing but our result. So we will call this one and we'll get our result finally here. So in this case if we'll talk about the you can say complexity, right. So time complexity will remain O of n and spaces remain 1 n, right. Why? The space complexity is O of n and time complexity also O of n, because see, when if there is n number of nodes, right, so we will visit each node at least once, right. Only once time we will visit, right. And the insertion order on either each of the DQ take a constant time rather than using the array or list data structure, where the inserting at the head would take the O of k times, where k is the length of the list, right. And there is one space complexity, right, and that will take what n is the number of nodes you can say in the tree. The main memory consumption of the algorithm is node queue, that we use the loop, apart from the queue that we use to keep the final output, right. So you can say at any time the node queue would hold the nodes that have at the most across the two level, right, you can say. Therefore at most size of queue would be the no more than 2, and if suppose L is the maximum number of nodes, right, so it can be 2 into L you can say, right. So finally we can say roughly if you take the binary tree, right, so roughly it will be L equal to n by 2, right. So if you'll talk about the space complexity, 2 into n by 2, right, so it become n in the worst case, right. So you can consider O of n as a space complexity also. Okay, so I think I have given you a very good concept here. So if you like this video, please hit comment, subscribe this channel, so that you will get more videos, right. If you want to see the DFS algorithm, right, based this one, right, If you want to understand the DFS based, so please ping me in the comment box. I will also write on the DFS based approach, right? Thank you so much, guys. Thank you so much.